What is the speed of light?
Oh, sorry.
Are you looking for a serious answer?
There's some math involved.
Yeah, there's a little bit of arithmetic.
186,000 miles per hour.
Do you think that I could measure the speed of light here in the market using chocolate chips?
Well, it's just a stupid question. It's no.
Challenge, you're throwing down the gauntlet. Okay, who wants to measure the speed of light?
Yes.
Oh, is Roddy the only one who wants to measure the speed of light?
Well, it must be difficult.
It's not difficult at all. How hard could it be to measure the speed of light? So what do we have on our table that would help us do that?
The microwave?
Microwave? What else?
I don't know, but I think she likes the chocolate chips.
We're going to use chocolate to measure the speed of light.
Yeah, that would be very original.
What do we have here that generates energy that travels at the speed of light?
A microwave.
Does a microwave put out light?
It puts out radiation, like light.
Exactly. We usually think of light as the stuff that we can see, but wavelengths of electromagnetic radiation, whether we can see them or not, are all the same basic thing. They're like forms of light, and they travel at the speed of light. Time to go to the chalkboard. The speed of light, give or take a few decimal places, is 300,000 kilometers per
Second.
second.
Per second.
Per second. The microwave gives us one other number. It's a really important number to figure out the speed of light. It puts out waves at a certain frequency. That tells us the number of waves per second. And that number is, Chris, can you hold that for me?
Yeah, sure.
2,450 megahertz. That's the number of waves per second. That's a lot of waves. Okay, and we call that the frequency. Okay, so what we're going to do is we're going to use the microwave to try to find out the one other thing that we need. If we know how many waves we get in a second, what would we need to know how far it traveled in a second?
Wavelength.
The size of the wave. If we can measure the wavelength, the size of the wave, and we know how many waves we have in a second, then we can figure out the speed of light. Now it's time to use the chocolate to see if we can measure the wavelengths of the microwave. Okay?
Okay.
Okay, so you're in charge of the chocolate chips.
All right.
Very important. That's our main scientific device here.
Okay.
I want you to create sort of a nice level layer of chocolate chips on that plate.
Okay.
It's like a chocolate chip pizza.
Yeah.
Okay? And what we're going to do is we're going to drop it into our oven. And there's one thing I want you to look at. It's really important in here. There's a plate on there that covers the rotating mechanism.
Okay.
So our chips are not going to rotate. They're going to sit in one position. On goes the microwave. We're going to put in 75 seconds. What happens to your food if you put it in there and you don't have it on the little turny plate?
It cooks unevenly.
That's because the waves in the microwave are focused in a particular pattern. They're standing waves, and there's certain parts where you've got the peaks and the troughs of the waves working together for maximum energy, and then they cross over, and at that crossover point, you get minimum energy. So what are the hot spots going to do to the chocolate first?
Okay.
They're going to melt the chocolate first. I think we've got just enough here. Oh yeah, we've got some melted spot. Ow! Kathy, can you pick up a few corks out of the bowl there? Take a few. Now that we've taken the chocolate chips out of the microwave, we're going to look for the hot spots. And we'll mark them with the corks, okay? There's a melty spot right there. There's a good melty spot right there.
And when
Yeah. The corks are now marking the hot spots. And if we measure the distance between the corks, that gives us half a wavelength.
All right.
Let's see what we get. So we'll pull this out. What do we have there?
6.
Actually, it's bang on 6. One there.
about 6.
6? Near a centimeter, what do we have?
6 centimeters.
6 centimeters. 6 centimeters is half a wavelength. Okay? So what would be a full wavelength?
12 centimeters.
Exactly. So our chocolate chip measurement gave us a wavelength of 12 centimeters, and we've got 2,450,000,000 of those waves every second. We have arithmetic to help us, so we do a little bit of math. If we multiply 0.12 meters times 2,450 megahertz, we end up with 294 million meters per second. We did it in kilometers before. You divide by 1,000. And what's the number that we measured in kilometers per second?
294,000 kilometers per second.
And what's the speed of light?
300,000 kilometers per second.
That's pretty darn close.
No, it's really
really
close.
Not bad for chocolate chips.
It's chocolate science.
The cock is in chocolate, white chocolate.
Science is so sweet.